So with that, let's talk about multiple choice questions. No one is saying that they're the answer to all of life's problems when it comes to creating exams, but they do have a role to play. They're appealing because they can be graded automatically. They can be randomized in various interesting ways, but there are some well borne out rules of thumb for how to create good multiple choice questions. So I'd like to go over some of those. The first advice has to do with writing the stem. The stem is the part of the question that you read before you start reading what the choices are. And a good practice is to make sure that the stem immediately focuses on the learning outcome. The stem immediately tells the student what the question is going to be about. So for example, on a previous quiz, we had a question that said, which of the following statements is true? Or if it's a select all that apply, you might say, which of the following statements are true? And then we gave the students various statements regarding the practice of unit testing. A better stem would immediately drive the student to focus on the learning outcome. We might write, which characteristic or characteristics are most commonly observed in unit tests? A related piece of advice is that a good stem should almost be a complete sentence. And if you follow the advice about making stems focus quickly on the learning outcome, this advice should almost come for free. But let me just give you an example. We had a question on a quiz recently that had to do with activities that are appropriate or not appropriate during the refactoring of a piece of software. So a sort of exaggeratedly comically bad question stem would be, you should, and then various choices of things that you do while refactoring. An improvement might be something like, appropriate activities and goals during refactoring include, and then having the same choices. But an even better stem, in my opinion, is to just write a complete sentence, which has less cognitive load for the student than finishing the incomplete sentence, and just write which activities or goals are appropriate while refactoring, and you can still have the same choices. So again, it gets right to the point. It makes clear what the question is about, namely refactoring, and it's in the form of a complete sentence, which your brain is sort of naturally primed to be able to parse and interpret very quickly. Stems that have sort of fill in the blanks. There's sort of studies that suggest that the cognitive load to process those stems is higher, but it doesn't actually test the student's knowledge any better. From a recent quiz, we wrote, mocks and blanks allow you to isolate behaviors in unit tests. If we try to rewrite this without the blank, we might say something like, besides mocks, what other mechanism allows you to isolate behaviors in unit tests? What other kinds of questions can you do? One example of an automatically gradable or multiple choice question is premise consequence. So for example, the question posits, suppose X happens, then which of the following will also happen as a consequence of that? You can ask incomplete scenario questions. For example, you could show a diagram of a system or a taxonomy or an architecture and something similar but maybe not identical to what they've seen in lecture or in their homework assignment, and then have students fill in the missing parts. In fact, for the missing labels, you can even have each missing label be a multiple choice question itself. Evaluation. Given a certain goal and a certain set of constraints, the multiple choices could ask which approach would be the best one to use. Now, of course, from the student's point of view, there's not really any way to get partial credit on these, because if the student chooses the wrong answer, there's no opportunity for them to explain their reasoning and get partial credit based on that. But right now, our focus is, what are some types of questions that address the higher levels of the Bloom taxonomy and can still be formulated as selected response questions, as opposed to constructed response, where the student has to essentially create new content to answer the question. And finally, an inference question. You give the students a statement and perhaps some other constraints, and you ask which of the following statements can be said to follow from the one that we gave you. So these are all types of questions that, although they don't really admit of partial credit, they do allow you to target higher levels of the Bloom taxonomy. How many choices should you have per question? Typical multiple choice question, we talk about the correct answer or answers and the distractors, which are the wrong answers that are put there to sort of catch common misconceptions. And as it turns out, there is a meta survey that has figured out the answer to this, and the answer is 3. Now, a caveat, the answer has to do with the specific scenario where all questions are a single correct response, and where the goal of the exam is to sort of cover as much breadth as possible. And the derivation of this is basically there's a fixed amount of cognitive load for the student to read and understand each choice for each question. So in some sense, your constraint is what is the total number of choices across all questions on the quiz? That's the sort of amount of student attention that you can get. Therefore, you want more questions with fewer choices if your goal is to maximize the information you're gaining about the student's knowledge across different areas. It's also been empirically measured because only plausible distractors will actually thwart guessing, right? You would think that a reason to have more distractors is to lower the likelihood that a student will get a question correct by guessing, but it turns out to be really difficult to write plausible distractors that actually do that job. The meta survey from which my data comes looked at a number of highly polished sort of career aptitude types of tests, and they found that only 16% of the time when they had a 4-choice single answer question, only 16% of the time did that third distractor get used. And when they went to 5-option questions, the 4th distractor only showed up in 5% of the responses. So empirically, even for experienced test writers, it's hard to create larger numbers of distractors that are really plausible and in fact thwart guessing. As I said, this is based on questions that are multiple choice with a single correct answer and where the student has a single attempt to get them right, which would be a typical scenario for an exam. And if you are interested in reading the paper, here's the citation, but I've summarized the most important high-order bits for you on this slide, and you're welcome. What about guessing? How can we thwart guessing? There are ways that you can create your questions that will make guessing a less successful strategy. One guessing strategy students use is they pick the longest or the most scientific sounding answer. So if you're going to create distractors, make all of the answer choices comparably long and make sure that they all make comparable use of keywords that students would recognize as being relevant to the topic of that question. Students will often pick choice B or choice C because if the questions have not had their choices randomized, the first and last choices, for some reason, students think they're less likely to be correct. You can order the choices truly randomly and let the students know that that's the case. A lot of quiz frameworks, including the basic ones in B courses, allow this. Or you can order the choices deterministically so that it's obvious, for example, that the choices are being presented in alphabetical order or in numerical order for the questions that have a numerical response. If a quiz platform you're using has the ability to randomize, the best thing I would say is to use that ability and let the students know so that they're aware that this guessing mechanism is not likely to work. Be very careful when you have either a correct answer or a distractor that contains the word always or never. Even in engineering classes, it's really rare that something is really always true or really never true. So students tend to shy away from answers that contain always and never. And our solution is to just be very careful and use those words very sparingly. Other ways to thwart guessing. If 2 choices appear in the list and they're opposites of each other, one of them is probably the answer. So either don't include choices that are opposites of each other or include 2 distractors that are also opposites of each other so that now they're really guessing between pairs of choices. True-false questions tend to more often be true. That's partially, I think, because as instructors, we don't like to write down things that are false and put that in front of the students. It sort of makes us feel dirty or something. So we just don't use true-false questions. And it's hard to write sincere-sounding false statements without feeling like we're selling out or something. So just don't use them. Use both forms of a question. So ask the question in a true form or ask the question in a false form and have different distractors. Or just avoid true-false questions entirely. What can you randomize? Depending on how you design your questions and what is supported by your quiz framework, the obvious things are randomizing the order in which questions appear, assuming that it doesn't matter, because, for example, groups of questions don't need to appear in sequence. You can also usually randomize the order in which answer choices are presented, as I mentioned earlier. Some systems allow pooling, where you provide a set of n questions that are arguably related, essentially testing the same thing but in slightly different ways, and you pick one question from the pool. And some systems also allow randomizing of parameters or hyperparameters or the structure of the question so that, in effect, you can generate different variants of the question for each student.